Okay, let's go. So I'm Daniel Stenberg. I work for wolfSSL and I work on cURL. Today I'm going to talk about what cURL is, who is using cURL, why they are using cURL, and who we are, who's making cURL, how we make cURL, a little bit about how we support it, and of course your questions and answers at the end if you have any questions. If you have any questions, you can enter them into the Q&A thing on the Zoom. So cURL, just to get everyone on board here, cURL is two things. It's the command line tool named cURL, and it's a library libcurl for transferring internet protocols used over the internet. So cURL transfers data using a lot of different protocols: file, FTP, FTPS, HTTP, HTTPS, IMAP, LDAP, POP3. HTTP and HTTPS, of course, are the most known ones, also the most popular ones, but cURL supports, I think it's around 24 different protocols today for transfer. So cURL is open source and has been from the beginning. I founded and started the project in 1998, and we've been working ever since. It is MIT licensed, and we support it at wolfSSL for commercial customers, and I am working for wolfSSL. I started a project, I still lead the development, I still do more than half of all the commits in the project. The cURL project has grown quite a lot since the beginning. As you can see on this little slide here, the number of lines of code have grown from the tiny little 2,000 lines back in 1998 up to 160,000 lines right now. It has really become this Swiss Army knife of internet transfer tools and libraries. cURL is widely used today. It is present in virtually every server software out there. A lot of Linux distros and other Unix distros can ship it by default, basically. It's a component in a lot of game consoles. This is the Nintendo Switch, which has it by default. It's used in a lot of devices. This is a fun kitchen thing which runs cURL. It is in watches and a lot of the other game devices and the video players. Netflix uses cURL in all their embedded devices, TVs and set-top boxes. Roku uses cURL. It's a very common component in computer games. This is the ending sequence of Grand Theft Auto 5. Right, and Fortnite is also a popular game using cURL. Apple TV uses cURL, of course. It's another set-top box, basically. It's a very common component for internet transfers in cars. Apple has shipped it in Mac OS as a default component for many years. It is in, well, in a lot of TVs at least, so a few 100 million TVs today have cURL installed. It is a component in Windows 10, the standard tool these days. And it is used in iOS, so in all Apple devices, basically iPads and iPhones. So we're now counting at around 10 million, 10 billion installations of cURL worldwide, quite a few. So why do all these users use cURL? There are many reasons, of course. So, and if you would ask any one of these, I'm sure they would all have their own specific reasons. But of course, I want to highlight that we do commercial support of cURL. So even if it's open, free, and available for everyone, we can still support customers up to 24/7. It is a very, very stable and well documented API. We have virtually not broken the API ever. We did that a little bit back in 2006, but examples back from the early beginning still work today if you upgrade to the latest libcurl. So you're safe. You know that when you upgrade curl, your code, your applications will still run. And a very powerful thing is that it's the same API everywhere. So wherever you go, you can use libcurl for your transfers, even when you go from operating system to operating system, or you do an application or a device that uses many operating systems, libcurl still provides the same API for all of them. And it's of course free. and I call it immortal because it's going to live on for as long as anyone wants to. It's also very solid. I call it battle proven, and we've maintained it and secured it and polished it for a lot of years. And not only has it then become a very stable product, it's also very customizable. So you can tweak and disable and enable the parts of the product that you want. And thanks to its sort of that it has been around for such a long time and worked over the internet for all this time, we've taken the time to make sure that the library speaks these protocols in ways that work. You know, protocols don't always actually work out the way they're specified to work, because servers and networks and everything have their own way of doing things. But over time, we've really made sure that cURL works as you want it to. Also, the fact that libcurl speaks many protocols is a really appreciated feature, as more than half of our users say and that they typically use more than 2 of the protocols that cURL supports. So even if you go beyond HTTP and HTTPS, cURL is there to help you do the internet transfers you want. And we're also very up to date, and we keep up with the standards and development. So we were early with TLS 1.3 support, and we were early with HTTP 2 support, and we are still early now again with HTTP 3 support. HTTP 3, of course, being the next HTTP version that is coming, and we're already on top of that, and we have an experimental support for HTTP 3 already in cURL. So all of these reasons are reasons why you should feel safe and secure by choosing libcurl for your products and devices. I mentioned you can customize cURL in a lot of ways, and that's true. That's really true. You can basically tweak it for your needs, and for that, for example, we provide the separate effort tinycurl, and I'll explain it in a second. It is also FIPS ready, that you can opt to build cURL with, for example, a TLS library that is FIPS ready. So you could, even if you have FIPS requirements, which is probably not, I'm not sure, but it might not be that common in Japan, but it's more of a US thing. And it is a very configurable build, so you can really tweak it when you build cURL or you choose cURL for your device or your specific environment. You can really make sure that cURL is built for that purpose. tinycurl, for example, it's a separate effort made to make a really small footprint library for HTTPS transfers. It's basically opting to strip out all the other protocols, building without that support for them, and making sure that it works for a few real-time operating systems using wolfSSL as a TLS library. And the aim there being that it should be smaller than 100 kilobytes in file size on 32-bit architectures. And we have ported it to FreeRTOS, and it's going to get ported to even more real-time operating systems going forward. So that's for the tiny devices, basically those that are too small to run one of the Linux, basically, or another larger operating system. And of course, we support this at wolfSSL. It is FIPS ready, so you can, since you can build cURL with a huge set of different TLS libraries. I think we support 13 different ones, basically all the popular TLS libraries, or you can select among all the popular TLS libraries, and wolfSSL is one of them. And as wolfSSL is FIPS ready, you could go with that and get a FIPS ready cURL solution. And of course, the API and how you use cURL still remains the same. It is the same API, and you would write your applications using this API the exact same way, even though. And we support this, of course, at wolfSSL. And you really can cherry pick individual features when you build cURL. There are, I think, over 50 different ways you can switch on and off different features and protocols when you build cURL in a standard way. And you can cherry pick exactly which third-party libraries you want to use or not use for your internet transfer needs. And you would do that for TLS, as I already mentioned, maybe SSH, maybe compression, or international domain names handling, or things like that. You can actually build cURL with a combination of up to 30 different third-party libraries. I mean, from 0 to maybe not all 30 at the same time, but there's a big selection of libraries to go with. cURL is also easily, I call it easily, ported to additional operating systems. So it has been ported to a lot of operating systems already, and it's fairly easy to go to another. I'll show you a little slide soon how many operating systems we already support. And of course, on all these operating systems, even if you switch operating system and you go with to a new one with cURL, it will still provide the same API. So your application doesn't have to be ported to the new operating system, just cURL, and then you could bring on your application. And of course, we support all that at wolfSSL. So here are some features that you can enable, disable when you build cURL. Depending on what you need libcurl to do in your device, maybe you don't need one of these, then you can switch it off. Maybe you want a few of them, then you switch them on and the other ones off to basically limit the footprint of the library for your particular need. You don't have to enable features that you're sure you won't need to get it a little smaller. And here's a little slide showing the 72 different operating systems that we know cURL has been ported to run on, just to show you basically the variety and the selection. That you can go to all these operating systems and still get a libcurl running. And I'm sure there are operating systems that I've missed on this little slide here. Quite a few of them. Honestly, I can't even name most of these operating systems myself, but yeah, and I think it's a very fine wall of OSs here. Yeah, and then of course, similarly, it has been run on these 20 different CPU architectures. And as you might guess, cURL doesn't really have any CPU specific code. So even if you have a 21st CPU architecture, I'm sure that cURL can be compiled to run on that as well. That's usually not a problem. And it just shows that we've taken care and made sure that it works in general very nice on all of these without a problem. So how is this done? You just need to read these 133 relevant RFCs for all the specifications that concern cURL and all the transport protocols. That equals to more than 260,000 lines of documentation. But of course, most of us who write cURL actually haven't read all of them, but some of us had read some of them, and together we've made sure that cURL works the way it does. And just the amount of documentation to do all these transport protocols, I think is kind of fun, because it equals up to an amount that is far more than all the words. This is how many words there are in all those specifications compared to number of words in different novels, War and Peace, Lord of the Rings series, and the Harry Potter series. They're all fewer words than the number of words in the specifications used to write cURL. Just a fun comparison. So who is making cURL? cURL is truly an open source project. We've been around since 1998, and already in 1998 we were more than one person contributing to the code and to the project. So in all, right now, more than 2,200 contributors have helped out to make cURL. And a contributor here is someone who is helping out in one way or another, writing documentation, writing code, writing bug reports, or anything else, or security problems, anything, helping out. Out of those, 820 persons have written code that has been merged into cURL. And roughly 150 of them are doing it every year. So basically we have 150 unique authors per year in the cURL project. And out of the 150, roughly 10, 12 do more than perhaps 10 commits per year. So it's just a small core team basically. And then there's me. I'm the only one who has done more than 10 commits for every year since 1998. So we're a huge team of contributors and authors, and but a smaller team of the smaller core team and me sort of at the wheel of the boat. And yeah, just show you here the graph, the number of contributors over time. So we've started out very few. Actually, the big jump in 2005 was me cleaning up the list, basically. But since then, you can see that we've increased the number of contributors all the time. Every year, we get a bunch of new people helping out in a project. So we're still a living thing. The number of authors in the project who have merged code into the Git repository still also increasing with well, almost 100 new first-time authors every year. So a lot of people are helping out. So still a huge interest in improving cURL and fixing things. So we've done 193 releases since 1998 to really make sure that this is something we all want. And we have roughly 50-60 contributors per release. And we do releases every 8 weeks. Since about 5-6 years ago, we do this very cyclic release schedule. So every 8 weeks on a Wednesday, we do a release unless something else happens. And we only ship source code, with a few exceptions, but typically we ship source code, and everyone else who ship cURL as binaries, they build their binaries themselves. So if you, for example, if you use cURL in a Linux distro or on a Mac machine or on a Windows 10, you're using builds that someone else built out of the source code that we shipped. To make sure that cURL is secure and safe enough for all these billions of users, we make sure that we review all the code, and we have a fairly strict code style these days to make sure that all code looks the same and it's consistent and should really look like it was written by the same person. We document everything, and then we have a very thorough and detailed documentation to help users, both users of the API and authors of the library. We have many tests, and we're increasing the number of tests all the time. We do CI builds and verify every commit and pull request very much. We have, I think, almost 90 CI jobs per commit right now. We, of course, run Valgrind and a lot of compiler sanitizers on every build. And we run 7 or 8 different static code analyzers on every commit right now to make sure that we don't let any stupid mistakes slip in. Still happens, of course. But we do this to limit the risks, at least, to do as good as we can. And we're also doing fuzzing. We're part of the OSS Fuzz project, for example, that is running fuzzing tests against cURL nonstop. And a few years ago, we had a code audit done by an external security company, and we have a living bug bounty. So we're paying security researchers for security vulnerabilities they can report. And we're now at 94 CVEs and counting. Of course, we never really end that journey, but we're really doing our best to make sure that there are as few and as low impact as possible. So when it comes to the code in cURL and how we test it, we make sure that we fix all compiler warnings, which is easier said than done on some systems, but on all modern systems and all modern compilers, we fix all warnings. We don't leave any defects left detected by one of the static code analyzers. And as I said, we run quite a few of them. And we always build, well, we build some of the builds with the most picky compiler options to make sure that all of these analyzers and picky compilers, they might hint about problems, and we fix them, and we add as many tests as possible. We have a few thousand tests right now, and we're continuously increasing that amount. And of course, we fix every known security issue as soon as possible. We encourage users to report security issues through our bug bounty program, and we're usually fairly quick at addressing the issues and fixing for any particular problem that we might have gotten reported. So how do we do user support in the project then, in the open source project? We handle issues, that is primarily then bugs on the projects, and pull requests as improvements to cURL on GitHub. And we have discussions, and we have user support for free for the users of the free software project and on the public mailing lists. We receive security issues and discussions on HackerOne. So HackerOne helps us run the bug bounty program, basically. And we have a lot of questions on Stack Overflow that are tagged with cURL or libcURL. Of course, Stack Overflow is a bit of a hit and miss sometimes. So some of the answers might not be the best. Some of the questions might be a bit confusing at times, but still, it is a fairly well-used forum for getting cURL help. And of course, if you wanted really swift, quick, fast, and accurate help with cURL, perhaps for your product or device, you get a commercial support from wolfSSL, and we can help you instantly and privately with whatever cURL issue you have. So cURL then, going forward, I used to show this little fun illustration because it shows basically what we're thinking. We're going to add more stuff to cURL over time, and exactly what we don't know. We, of course, have a tiny roadmap, and I'm not going to get into that exactly right now because I think it'll you can find that out if you really want to, but I wanted to more highlight that you can, of course, help configure the future as well. I mentioned cURL is very configurable. As a customer of cURL support, you can, of course, configure the future. So we do custom development of cURL on demand. So if you miss something, or if you have a particular problem with cURL right now that maybe is an obstacle for you in your product or whatever, you can get that fix right now or added feature right now. And we typically merge our fixes, the fixes we do for customers. Most customers want them to get merged into cURL so that we can continue using the regular cURL going forward. But of course, if you pay for a custom development, we might not have to upstream it if you don't want to. And of course, we support all this at wolfSSL, so just contact us and we will help you figure out exactly what to do and how not to do, and if we can do it or when we can do it. So this was a really quick run through about cURL, what it is, why people are using it, tiny cURL, and our bunch of our services at wolfSSL. Here are some links about cURL and the cURL website at the top, the wolfSSL.com product site page in the middle. And I wanted to add, because I just got to know that it's not present on this slide, but there is now information about cURL and tiny cURL in Japanese on wolfSSL.jp on the website there. So thank you for listening. This was what I wanted to share with you. And if you have any questions, thoughts, or whatever, head over to the Q&A tab here on Zoom and ask it. Ask it in English or in Japanese. And if you ask it in Japanese, I guess I can get some help from someone to translate it to English. Otherwise, I think I'm done here. Thank you.